Hello students, very good evening, good morning, good afternoon, whenever you are watching this video. Now in today class, I am going to start a very important chapter. Trust me, if you understand this chapter fully, then you didn't have any problem in alkyl, aryl, aldehyde, ketone, alcohol, phenol, ether, carboxylic acid, amines. Any chapter you will not find a single difficulty, that is my guarantee. From here, you are able to understand organic chemistry. And I will try, not guaranteed. I will see after making what will happen. I will try to make this video as one shot. If one shot I will complete, you can watch either in 2 times or 3 times, but definitely you will complete it. Okay? Now, up to now, what I have studied in organic chemistry, this is the preparation, that is the preparation. Now, my way of teaching is totally different. What is different, sir? In Grignard reagent, I have taught you one shot, everything of Grignard reagent at one place. Similarly, qualitative, quantitative analysis, each and everything at one place. Similarly, hydrocarbon, I will teach you in such a way that you will realize how to learn, how to understand the topic. Sir, what you are saying, we are not getting it. Don't worry. Just see the way of my teaching. First of all, I will dictate you something about free radical. First, I am starting free radical mechanism. And I will not dictate you mechanism first. I will dictate you something different. Just see it very properly. A very good notes also I will provide. I will go a little bit slow. So if you want to study it fast, you can make it 1.5, 1.75 like that speed. But more than 1.5 is not good. You have already studied about free radical in chemical bonding. What do you mean by that, sir? Suppose I have written CS3 dot. And one place I will write CF3 dot. Leave dot. I will not write dot. Just see. Suppose I have written CS3 and I have written CF3. I will ask you what is the hybridization you will get. Hybridization. So to find the hybridization, we have to use the formula steric number. Sn means steric number. And those student has studied chemical bonding with me, I will teach you chemical bonding in different way also. Don't worry. Sir, what you are talking about? Just concentrate over here. Hydrocarbon. Hydro means you already know basic things. Hydro means hydrogen. Sir, why you are teaching this? Just trust me. I want to give you a very good notes. Hydro means hydrogen and carbon means carbon. It means carbon means carbon. So this chapter basically contain a hydrogen and carbon containing compound. This chapter basically contain hydrogen and carbon containing compound. So the name of this chapter is hydrocarbon. In that chapter, first topic I am going to teach you, and the name of the topic is free radical mechanism. Before going with that topic, I will say you suppose one example I have written CH3 and another example I have written CF3. And I will tell you yes, my dear students, tell me what is the hybridization of CH3 and what is the hybridization of CF3. You will say, sir, I didn't know the formula to find hybridization. But I will tell you steric number is equals to surrounding atom plus lone pair. SA means side atom or surrounding atom. And LP means lone pair. Now, first I will say, okay sir, I am going to find for CH3. First question I will ask you, yes bachche, tell me what is the valence electron of carbon. Sir, valence electron of carbon is 4. Okay. And hydrogen has 1. How many bond hydrogen will form? 1 bond here, 1 bond here, 1 bond here. Now, if you will use the formula for steric number, what you will say? How many surrounding atom? Sir, 3 hydrogen plus lone pair I have written, but over here unpaired is there. So whenever side atom is less electronegative than central atom, carbon is central atom, Ca means central atom, and Sa means surrounding atom or side atom. Whenever central at side atom, SA means side atom. I will write each and everything. Sir, why you are writing? Just I am saying now, if you want to go slow or fast, there is an option in the YouTube you can do. CA means central atom. So whenever the side atom is less electronegative than surrounding atom, then unpaired is not considered inside hybridization or steric number. Does not consider inside steric number, and vice versa. Vice versa means if surrounding atom is more electronegative than central atom, then it will be considered. So steric number is coming 3. Hybridization is sp2. But if I will go with CF3, what you will say? Carbon has still 1, 2, 3, 4 valence electron. Fluorine forms always one bond. Here one bond, here one bond. Over here, if you will find the steric number, what you will say? Surrounding atom of CF3 is 3 fluorine is surrounding. Plus, this time unpaired is considered as a lone pair. It will come inside the hybridization, and their hybridization will become 4, and it is coming sp3. You know that sp2 means trigonal planar. This chapter is very important, so I will go a little bit slow. If you know something, then you will do 1.5x speed. And sp3 is tetrahedral. First question they will ask, ki in the CS3 one dot is left and in the CF3 one dot is left. Tell me where this dot is present. So you will say this dot is not going inside hybridization. This dot is not going inside hybridization. So this will present in pure p orbital because carbon has p orbital. But over here this CF3 dot is present inside sp3 hybridized orbital. Understood? Because that CF3 dot is taking part in the hybridization. So over here unpaired electron is present in sp3 orbital, but over here it is not present in hybrid orbital, it is present in pure p orbital. P. The first free radical, you have understood two types of free radical. One free radical in which side atom is more electronegative than surrounding, and one free radical is that side atom is less electronegative than surrounding, in which side atom is less electronegative than it will present in pure p, side atom is more electronegative than it will present in hybrid orbital, that is sp3. In this hydrocarbon chapter, we have to study about SCH3 dot. We didn't have to study about CF3 dot. This topic is not there in this chapter. Now, first you understand this part. Now, after this, as I will ask you, ki over here, you have a one formula, N is equals to number of unpaired electrons, and mm, that is also denoted as mu, and that is called magnetic moment. If I will ask you what is the magnetic moment formula, you will say N into N plus 2, where N is the number of unpaired electron and their unit is Bohr's magneton. So if I will tell you to find the magnetic moment for CS3 dot, so how many unpaired electron it has? Sir, only one unpaired electron it has. The structure you have already seen. Over here, if you will find magnetic moment, what you will get? Under root 1 into 1 plus 2 Bohr's magneton. That is coming under root 3 Bohr's magneton. That is coming 1.73 Bohr's magneton. It means magnetic moment of CS3 dot is 1.73. And there is a rule. If magnetic moment is 0, that type of compound is known as diamagnetic, and that type of compound is colorless. Another way of dictating is, if magnetic moment is not 0, anything 1, 2, 3, 4, 5, 6 negative to not coming, na integers coming, not integer, natural number coming, then it will become paramagnetic. And whenever it is paramagnetic, it has some color, so we will call it as colorful. So from here we will write कि free radical, any free radical, especially I have taken CS3 dot, but any free radical if we will talk, what I will say, their magnetic moment is not zero, as well as if not zero, it means free radical are paramagnetic, and that is colorful. Acha. If I will check this free radical H and H, one dot, how many electron this carbon has? Sir, 1, 2, 3, 4, 5, 6 and 1, 7. It means free radical is only has 7 electron, so it is known as odd electron species. It has 7 electrons, so it is known as odd electron species. After dictating this, now I am going to write some important points regarding free radical. I hope you have understood. This chapter I will not do 2 to 3 times revision, otherwise you will get confused. Slowly I will teach. If you are not understanding anything, you will go back and see the things. Some important points, some properties of free radical. After dictating something about free radical, I am going to dictate you some important properties of free radical. What is that important properties? Slowly, sir, don't panic. I am also not panicking, and I will suggest you all also not to panic. If you need something very fastly, you can see in 1.5x speed. Don't say, sir, you are teaching slow. Handwriting, I will write very good. First important point I can write, and this chapter is very important, sir, trust me. Those who are able to understand this chapter, after that electrophilic aromatic substitution, for them organic chemistry became very easy. Now first important point, can I say it consists of one unpaired electron which makes it paramagnetic and colorful. Just now I have proved it also by doing it. But we have got magnetic moment is equals to 1.73 Bohr's magneton. H. Second and very important point is it is highly unstable, and it has zero activation energy. What do you mean by that? Suppose if you will boil water, so at least water needed to go to 100 degrees Celsius before it will evaporate. Similarly, everything needed some activation energy, but it has zero activation energy. First important question in advance has been asked. What is the activation energy of free radical? So it has zero activation energy, so that whenever you will draw the graph for potential energy versus reaction coordinate, their graph will coming like this. Previously potential energy is high, and suddenly it will become low because zero activation energy. It will not wait for anything to do. This is the graph. If potential zero activation energy, it means it will not need activation energy is there. Then we are drawing the graph like that. It is activation energy. We will not have to draw like that. Simple. This is the graph because it has zero activation energy. Third important point, can I say it is incomplete octet because one electron is not going to form a bond. So it is incomplete octet, and as well as odd electron species. I have written just now, it has 7 electron. Fourth and very important point, that as it has zero activation energy, so whenever you will get 1 degree and 2 degree free radical, whenever you will get 1 degree and 2 degree free radical, it will always do combination reaction. It will always do combination reaction. Don't worry, I will write lots of example and I will dictate you. And whenever you have 3 degree, whenever you have 3 degree free radical, then it will always do disproportion reaction. What it will do? Disproportion reaction. Whenever it has 3 degree free radical, it will do disproportion reaction. As well as next important point, what is 1 degree combination free radical? I will dictate everything, don't worry. Fifth important point, that it can also do rearrangement. Wait, sir, we have studied only carbocation rearrangement. No problem, not in our syllabus, not a part of syllabus. This topic we didn't have to study in JEE level, advanced level. So rearrangement is not there. But suppose they will ask advanced, so anything they will do, no, they will ask, can we do rearrangement in free radical? Don't say no, yes we can do. Acha. Sixth important point, we know that whenever free radical is there, the rate of reaction is always depends upon stability of free radical. And I have already dictated you GOC. So over there you can see the stability of free radical, how we will judge it. Understood this all point? Sure short, everyone? If not understood, see it again. If I will do revision, again they will get confused. But I am just saying you for simple way. First, two types of free radical. Whenever a side atom is less electronegative, then unpaired is not considered inside. More electronegative, it will be considered. So whenever they will ask CS3 dot, where the dot will present? In the pure orbital. But CF3 dot, where the dot will present? In sp3 hybridized. In our syllabus, CS3 dot we have to study. Then I have find the magnetic moment under root n into n plus 2. I have put the formula and I will get the result. After that, I have dictated you whenever there is a magnetic moment 0, then we will say that compound is a diamagnetic. And whenever magnetic moment is not 0, that compound is a paramagnetic. And colorful, it is colorless. On that basis, we have seen free radical, that it is colorful because it is paramagnetic and colorful. 7 electron, odd electron species. First, it contains 1 unpaired electron. Second, it has 0 activation energy, highly unstable. Incomplete octet, odd electron species. Odd electron species means 7 electron. Odd electron species means 7 electron. 1 degree and 2 degree free radical will do combination reaction. And 3 degree free radical will do disproportion reaction. And it can also do rearrangement, but it is not in our syllabus. And rate of reaction is directly proportional to stability of free radical. I hope you have understood what I am trying to say. Sir, we didn't understood the fourth point. What do you mean by 1 degree will do combination, 2 degree will do combination, 3 degree will do disproportion? Don't worry. I will show you some questions regarding that. Now, if I will see the question that 1 and 2 degree will do combination and 3 degree will do disproportion, suppose some questions we have. Whenever they will give the question, always try to understood either written or not written, it is 2 mole. Whenever there is a question written or not written, always consider it as 2 mole. Written or not written, always consider it as 2 mole. Written or not written, always consider it as 2 mole. Automatically. Now, it is 1 degree, 2 degree, 3 degree. Sir, it is 1 degree. So it will become double. CS3 combination. It is 1 degree, 2 degree, 3 degree. Sir, it is 1 degree. So CS3, CH2. Then again CH2, CH3. Double it will break. This can also be drawn like this. 1, 2. 2 carbon. Then 1 extra bond. Then again 1, 2. It means whenever 4 carbon is coming, this 2 means this and this CH3, CH2, CH3, CH2. This is in the middle is an extra bond. Achha. Why I am dictating this? So you will not get confused how to draw it. First understood, second understood, yes sir. Third part, what you will do? Sir, it is also doing combination reaction, and after combination what it will become? 1, 2 is there, another 2 will come like this. Okay sir, directly double in that way. Achha, sir, this is also 1 degree. What I will do? 1 degree and 2 degree, both will do combination. There, then 1 extra bond, then after that this, and this is opposite. It means this is one part of 2 mole, and this is another part of 2 mole, and this is the bonding between them. So don't get confused in that. Over here, sir, Over here it is also 1 degree. Either double bond is there, but it is coming on 1 degree na. Ha sir. Here, then after that one extra bond you will form, then again here. Understood? It means this is first original structure, this is second original structure, and this is the bond that is combining these two structure, this bond. Understanding? Acha, over here also benzene ring. Ha sir, it will also do combination reaction. Here again, here this is combination reaction. Acha sir, this much easy. Yes. Acha, in this part if I will do resonance also, here and here, what you will get? Double bond coming here, resonance coming here, and if you will do 2 mole considering, so it will also do combination. It will also do combination. So this product and this product is looking same, so I have not done the resonance. I have not done the resonance. See any difference in these two products? No sir, looking exactly same. So they are not doing resonance. I have not done the resonance. But if you will see there, what is the things? First you will say ki sir it is 1 degree. Okay sir, 1 degree will do combination, 2 degree will do combination. So first I will do the combination reaction. Here double bond, here. After that I will make one extra bond, that to combine both two, and then again I will come 1, 2, 3, and here double bond. This is coming combination. But someone will say, nah sir, I want to do resonance over here, resonance over here. This will become dot, this will become dot, and because of making the dot, it will become another compound. How sir? Here double bond coming, now dot shifted here. Now once the dot shifted here, what is the another product you will get? Sir, this, and on the top side this double bond. Yani over here two different product coming, because allylic means benzene double bond pi sigma free radical will do resonance. So whenever it is doing resonance, you have to try to do the resonance. So this product is one product, this product is second product. After resonance, combination only doing. All are doing combination, but resonance possible, so you will draw the resonance also. Over here no need to draw, because in this structure both structure is looking same, so I have not done resonance. But over here both structure is not looking same, so I have done the resonance. Now this is good example. What is good example? Sir, it is 3 degrees sir. Up to now 1 degree and 2 degree coming, so 3 degree will do disproportion. 2 mole is there, so what you have to do? You have to take 1 mole and you have to take another mole. 1 mole has free radical, another mole has free radical. Now on the first mole, any one place, either this place or this place or this place, any one place you have to check hydrogen. Yes sir, this is the hydrogen, and do free radical from here, dot and dot, and this dot combine together to form double bond, and this will come here. It means you will get the product here double bond, and here one hydrogen. If you will write hydrogen or not write, it will be as it is. Sir, everything I understood, but I didn't understood this 3 radical things. Don't worry, simple. If 3 radical is there, 3 degree is there, suppose here I will make double bond. So you will do one thing. First you will make one compound as it is, and then try to put double bond here or here, any one place. But while putting, check which double bond is more stable. Sir, this double bond is more stable because of more number of alpha hydrogen. So this is the 3 degree answer. No sir, not understood. Acha, okay. Suppose I will draw the structure like this. Here dot 3 degree. So one structure you will draw as it is. What is the given structure? As it is will be the one answer, without removing the free radical. Another will be double bond coming. As it is, draw the structure, and then where you will put the double bond, so this structure will become more stable here. Now understood? So 1 degree, 2 degree, direct combination. But 3 degree, one is alkane, one is alkene. 2 product will come in 3 degree. So I hope you understood about the basic part. So at the last, can I write, if we will have 1 degree and 2 degree free radical, it will do combination, and product has double carbon, then reactant. If reactant is 1 carbon, product has 2 carbon. Check every place. here 1 carbon, here 2 carbon, here 2 carbon, here 4 carbon, here 1 2 3 carbon, here 1 2 3 4 5 6 carbon, double coming. हाँ sir. But if it is 3 degree free radical, then it will do this proportion, and in this proportion you will get one product as same as it is alkane, and another product you are getting alkene, and especially those alkene that is highly stable alkene. Which alkene? Highly stable. How we are checking the highly stable alkene? By checking more number of alpha hydrogen, and that you have studied in hyperconjugation. So do you know what I will do right now? I will do all the reaction of whole organic chemistry I will teach which contain free radical mechanism. Understanding? First basic things I have dictated you about free radical. Now I am going to do all the reaction that contain free radical mechanism. So it will be very easy for you to understand this topic. This is question number 9th. This is question number 10th. Understanding, sir? Any confusion? Seriously, if you have confusion, see it again. I am saying this video is going to be more than 3 hour, 4 hour. I didn't know. Just now I have started and I am trying to complete it for all one shot. I am going to be successful or not, that I am also not sure. Yes, up to now you will revise. I am going to dictate you the next part. Now we will see. My teaching is first free radical. Don't get panic. If you will understand the way of my teaching organic chemistry, you started enjoying organic chemistry. Trust me. Now, after that, I will dictate you all the reaction that contain free radical. Whole organic chemistry, sir. Whole. Arey, sir, this is the very good idea. Okay. Now, we are going to see the reactions of free radical. What we are going to see? The reactions of free radical. What are the reactions? What is their response? Everything we are going to see about free radical. And this chapter notes will be very good because it is one of the good. Those who wants to download these notes, they can see the comment, not description. Because I didn't know how to upload in description. Comment I am able to, so I am uploading over there. Now, first reaction we will have is urge reaction. What we will have? Urge reaction. In urge reaction, I will take sodium. I will take sodium as a metal. I am taking sodium as a metal. Sometime it is also written in the book. What is written? In presence of active metal sodium. What do you mean by that? Active metal? Active metal means those who will react, they will lose the electron. Now, what is happening in urge reaction? First sodium will come, and you know that sodium will always release one electron. What it will release? One electron. And you have to take one alkyl halide. You already know R is alkyl and X is halide. Alkyl has a formula CnH2n plus 1. And halide is fluorine, chlorine, bromine, iodine. I will try. I will not take fluorine. I will try it because fluorine is not good. The chlorine, bromine or iodine I will take. So suppose I have taken alkyl halide. We know that electronegativity of halide is always more than electronegativity of alkyl. And in GOC I have dictated you first video, it will do heterolytic cleavage. Once it will do heterolytic cleavage, it will get minus, it will get plus. This cleavage is known as heterolytic cleavage. Heterolytic cleavage. So I am saying now, before coming to here, you have to be very good in GOC part. Heterolytic cleavage. Now, once the R plus will form, the electron from sodium will come, and they will say R plus bhaiya, take my electron, and it will take the electron, and it will become R dot plus X minus. Now, just now I have dictated you कि once the dot will form, if this dot is forming 1 degree and 2 degree, directly you will do combination, and with the combination it will become R and R, that it will become alkane. And if it is coming 3 degree, then you will do this, and just now I have dictated you how you will, question also I will dictate more, don't worry, and it will form one alkane and one alkene. Just now you have seen lots of example regarding that previously done sodium Wurtz reaction. This is happening in Wurtz reaction. Now some important points I am going to write about Wurtz reaction. And in chemistry, important points for organic chemistry is known as stereochemistry. Important point is known as stereochemistry. So don't get confused कि what do you mean by stereochemistry. So we are going to see stereochemistry for Wurtz reaction. We are going to see the stereochemistry for Wurtz reaction. What are the important points it has? Okay, sir, dictate us. We are waiting for that. Okay. And I am not putting any watermark like for my YouTube channel कि whenever you will download notes my name will come. No, I don't want to become that much popular. I just want your love, and once you will get selected, please give me one gift after your JEE exam. I will be very happy with that, and I will arrange that gift as my house for future purpose, to show off others कि see, these are the students who qualified in JEE. अच्छा sir. Now first stereochemistry I will say कि in Wurtz reaction what is happening? Sir, free radical is formed. Free radical is the intermediate, and in GOC I have dictated you free radical, carbocation and carboanion is always coming intermediate. So if anybody is asking, rate of reaction is directly proportional to a stability of free radical. How much stable the free radical is, easily the reaction will happens. Okay. Second important point, if they will ask you कि we have Ri, Rbr, RCl and Rf, in which part Wurtz reaction is happen very fastly? So you will say in I, then in Br, then in Cl, then in F. Why? Because of leaving group. Because of leaving group. Iodine is easily leaves the alkyl. After that bromine, after that chlorine, and after that fluorine. This I am writing for free radical, but this is valid for each and everything. This is valid for each and everything. What do you mean by that? If SN1 coming, SN2 coming, E1 coming, E2 coming, free radical coming, anything coming, leaving group needed to be very good. And over here leaving group is iodine, then bromine, then chlorine, then fluorine is always in every cases. So this is the second important point. Third important point is that what is the metal you are taking, sir? Sir, we are taking metal. Sir, what you have written before that, that only making the point? Yes. So that you have a very good notes and very good understood. I am saying na कि we are able to do each and everything about hydrocarbon, but because for me hydrocarbon is one of the most important reaction, important chapter. Fourth important point कि if 1 degree and 2 degree, then it will do combination. Sir, how many times you will write? As much time as is possible. And if it is 3 degree, then it will do disproportion. Okay, sir, this point we understood it. Go with next point. Fifth important point, what you will see कि symmetrical alkane is formed. Symmetrical alkane is formed. Symmetrical alkane is formed, that is also known as even number of alkane is formed. Even number of alkane is formed. What do you mean by that? See, every example of free radical, how many carbon it has? See from starting. First has 1 carbon becoming what? 2. Second has 2 carbon becoming what? 4. It has 1, 2, 3. It will become 1, 2, 3, 4, 5, 6. Product is always even. Check. 1, 2, 3, 4, 5, 6, 7, 8. Product is always even number of carbon coming. Product is always even number of carbon coming in free radical mechanism. Always even number of carbon coming. Sixth important point, and it may be this will ask in the advance as a point. Does carboanion is also formed in carboanion is also formed in Wurtz reaction? Yes, sir. Carboanion can also be formed in Wurtz reaction. Can also be formed in Wurtz reaction. Sir, just now you have said free radical will form. Always free radical will form. But if theoretical question will come, you will say yes, carboanion can also form. How, sir? See, sorry. Whenever you are doing mechanism, one sodium is there. If I will take 2 sodium, the 2 electron will come, 2 electron will go. So R dot will become what? R minus. First it will become dot. 2 electron coming. It is written as R minus. Understanding? It means there is a possibility of carboanion. How? If 2 moles of sodium is there. If 2 moles of sodium is there. But you didn't have to make carboanion any time. If this theoretical question will come, then you will write. Practically always free radical. Okay. Acha, seventh important point, you will see every place CH4 not prepared. See, every place. CH4 not prepared. Any place you will check. 1 carbon you will take, what it will become? 2 carbon, na sir. 1 carbon will become 2 carbon. So how you will form 1 carbon? Yani one problem coming, CH4 cannot be prepared in Wurtz reaction. Eighth important point coming, and that what I will do now, understood the point. First I have dictated free radical. After dictating free radical, I have dictated you the reaction of free radical, and first reaction is Wurtz reaction. In that, what is problem coming? First coming is CH4 not prepared. So next reaction I will dictate you how to prepare CH4. Oh, second important problem coming कि we are not able to produced odd number of carbon. If you will take 1, became 2, 2, 4, 3, 6, 4, 8, 8 means always you are forming symmetrical alkene and even number of carbon. You are not able to form odd number of carbon. It means first understood the way of teaching my organic chemistry. First I have dictated you that what is free radical. Then I have taken free radical first reaction, Wurtz reaction. In that Wurtz reaction we are facing 2 problems. First problem is that we are not able to produce CH4, and second problem is that we are not able to produce odd number of carbon. Then after that I will teach you which of the following will produce CH4 and which of the following will produce odd number of carbon. It will become very easy for you how I am teaching it. Understanding the point what I am trying to say? Yes sir, we are understanding. Now over here, if we will see Wurtz reaction, so Wurtz type lots of reaction is coming. What do you mean by that? It means first I have dictated you Wurtz reaction. Now I am going to dictate you next reaction, free radical only. I am not preparing CH4, not preparing odd number of carbon. That I will do later. First I will see which types of reaction is same as Wurtz, and then I will see some questions of Wurtz reaction. Then at last we will do CH4 preparation, then odd number of preparation carbon. Job done. Understanding, sirs? Acha sir, like that you will teach. Yes, my dear friends. Now next topic I am going to start Wurtz family. Wurtz reaction we have seen. Some of the scientists came and who is giving the reaction just like Wurtz has given. So I have named it as Wurtz family. See, what is the easy way to learn? And all Wurtz family, all will follow free radical mechanism. All will follow free radical mechanism. Means 1 degree and 2 degree combination. Sir, how many times we will write this? All the time. 3 degree disproportion. 1 degree, 2 degree combination, 3 degree disproportion it will do. Now I am going to write all the reaction that is coming in Wurtz family. So first of all, I will say, sir, Wurtz reaction. What the Urj sir has done? He has taken alkyl halide. He has taken alkyl halide in presence of sodium. Moles I will not write ki 2 mole here, 2 mole here. If not given also you have to understood it. In presence of little bit dry ether. Sometime question coming, why dry ether? See, understood. What is happening? Ki Na is breaking 1 electron, became Na plus and 1 electron. And Rx is breaking and becoming R plus X minus, and it is giving the electron, and because of that it is becoming R dot. Question is that why it is taking the electron? If he needs the electron, why it will not again combine and become this product? So we are using dry ether. What the dry ether will do? Suppose Et2O and Et2O, dry ether. R plus coming, it will solvate it. Plus is there, they will say don't worry. Suppose some girls is getting breakup, so some boys is coming and saying don't worry, I am your best friend, I will take care. Similarly, R has got breakup, and this Et2O has lone pair of electron. They will come over here and say don't worry, don't worry. So it will not again go with X and not X, yes, not that X. Now, so what we will write in a chemistry language, we are writing to solvate. Dry ether is used to solvate. This is the term we are using in Grignard reagent also you have seen. Okay, sir. Welcome back to the topic. In Urj reaction, what you have seen, ki Rx will react with, here I will make one line so you will not get confused. Okay, sir. Now, over here, what will happen? Rx is react with sodium in presence of dry ether. It will form R and R. NaX will form outside. That I will, what is the use of writing, that you know already. Precipitate is there. NaCl, NaBr, NaI, like that. Now, Urj sir has written this reaction and not try for other things. And he will go in the pub with his girlfriend and enjoying the life. Yes, I have discovered. Yes, I have discovered. Whenever he is enjoying, at the same time, one scientist came, and whose name is Fitting. He said, कि सैया भैया मेरे, you have dictated alkyl halide, I will take aryl halide. pH means phenyl. You have taken sodium, I will also take sodium. You have taken dry ether, I will also take dry ether. But I will take little bit amount of heat. But I will take little bit amount of heat. So what happens? Like that you are forming alkyl, I will also form the biphenyl, and NaX will come. Now Urj sir started crying, Bhaiya, it is cheating. You have taken all my reaction after putting heat. You have taken the credit and you have given the name. Right now Urj sir has not stopped crying. At the same time, one more scientist came, whose name is Uleman. He is saying that, Acha, Rx and sodium and PHX sodium, do one thing. I will use another part. What I will do? I will take PHX and copper, and I will get PH biphenyl plus CuX2 copper halide, because copper has 2 valency to CuX2. Urj sir saying, Arey yaar, what rubbish is this? I am discovering something. Everyone is coming and ruining this and taking the all credit. Now still he has not stopped crying. At the same time, one scientist came, Frankland, and he is saying, Bhaiya, you are playing with alkyl aryl, I will play with something. What I will play? Either you will take alkyl or you will take aryl. Take zinc as a metal. Take zinc as a metal. Dry ether everyone is using. Dry ether and heat everyone is using. Over here it is also using dry ether and heat. He is also using dry ether and heat. Zinc as a metal. You will take zinc as a metal, and then up to now Urj sir is doing for only alkyl. Urj sir is doing for only alkyl. Fitting is doing for only aryl. Uleman is also doing only aryl. But the scientist, whose name is Frankland, he came and as he said, I will give you zinc metal, and that zinc metal is used for alkyl also, and ZnX2, and aryl also, PH and ZnX2. Now Urj sir taking the breakup with his girlfriend and started crying, कि भैया, you all have cheated me. I have initiated the reaction. You are just changing the metal and you are taking the credit. Fitting has taken sodium, heat taken little bit, and aryl he discovered. Uleman has copper taken, again discovered aryl. Franklin are doing both the things, taking zinc. What I will do? and he will go into the depression. You said na, depression. He will go into the depression. At the same time, fitting sir came and say, sir, don't worry. You have only one name. I will give you one more name. I will not take your whole credit. I am your best friend. I will do one reaction, and that reaction is urge fitting. Means fitting sir has also not removed his own name, but he has given the credit for urge sir also regarding this. And in that credit, what he has said, he said, sir, you have taken alkyl, I have taken aryl. Both we are going to take alkyl also, and we are going to take aryl also in presence of 2 mole of sodium, every place 2 mole, and dry ether in presence of heat. So we will get PHR. pH means this, benzene ring with alkyl group. So this is the all reaction that will show urge family. It means what is the reaction you have seen in urge family? Sir, urge, sodium, alkyl, fitting, aryl, sodium plus heat, Ullmann, copper, Franklin, zinc, and urge fitting, alkyl and aryl both together with presence of sodium, and each and every reaction is doing free radical. Above all, urge family is doing free radical mechanism. And if all is doing free radical mechanism, so if R is 1 degree and 2 degree, then it will do combination, and aryl, pH is always 1 degree only, na? And 3 degree, it will do disproportion reaction. Now understood? Free radical we have done. Now after this we will some questions, and in free radical urge family we have found 2 problem. Problem number 7th, CH4 not prepared and odd number of carbon not prepared. After doing the questions, we will see the next reaction to prepare odd number of carbon. But before that, some student will say, sir, why you are not doing like this? You will do like this. What I will do, sir? You will do one thing. 1, 2, 3. Propane you will take. 1, 2, 3, 4. Over here Cl you will take. Over here Cl you will take. And try to produce in presence of sodium, dry ether and heat. Odd number to coming na sir. Here it will go free radical coming, here it will go free radical coming, not like this, it will go homolytic cleavage it will do. So try to do like that. Here dot will come, here dot will come, and this dot, 1, 2, 3. After that one bond, then 1, 2, 3, 4. Odd number to coming na sir. This is the bond. Odd number to coming na sir. What is the problem? Over here you are getting the odd number sir. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. One extra I have made. I will erase it and I will dictate you. 1, 2, 3, 1, 2, 3. This coming 1, 2, 3. Then one extra bond. Then 1, 2, 3, 4. 1, 2, 3, 4. How many carbon coming, sir? Sir, 1, 2, 3, 4, 5, 6, 7. Sir, odd number to prepare, sir. You have written 8th number point. Ki we are not able to prepare odd number of carbon. Hi, sir. How, sir? Over here to prepare, na? You have taken, na? You are saying, na, ki whenever you are taking CS3, you are taking 2 mole. Instead of 2 mole, I have taken 1 mole this, 1 mole this. I have not taken one thing 2 moles. I have taken 2 things 2 moles. What is the problem coming? This product to coming. No problem. No problem. But this is 1 mole also. 1 mole means 6.022 into 10 to power 23 atom. So 3 product will come. It itself doing combination. 1, 2, 3. 1, 2, 3. One product will come here. From here 1, 2, 3, 4. 1, 2, 3, 4. It means one product this, and 3 different product coming. Suppose you will take only this 2 mole Cl. So what you will get? 1, 2, 1, 2. This you are getting. How many times you are getting? You are getting only this part. Na? You are not getting anything extra. Na? But over here, there is a possibility you will get 3 different products. And these three different, why? Because 1 mole doesn't means 1 piece. 1 mole means 6.022 into the power 23 atoms. Lots of pieces are there. So there some atom will attach with themselves and forming this. There some atom will attach with themselves forming this. And these two is combining forming this. It means in this case you are getting mixed product. What you are getting? Mixed product. 2 to 3 things. And it will give very bad yield. It will give very bad yield. Bad yield means bad quantity. Very less quantity, each and everything will come. So I have written one point now over here. Ki symmetrical alkane is formed. Always symmetrical alkane is formed. Unsymmetrical odd number, don't try to form it. If you are taking this, take only this of 2 mole. If you are taking this, take this only as 2 mole. It means I am saying that if you have taken 1, 2, 3 here Cl, so another also you will take 1, 2, 3 here Cl. This and this must be same in presence of sodium and dry ether. If you will change these two, 1, 2, 3, 1, 2, 3, 6. If you will change these two, then answer is not good and that will not valid for Urge reaction. So odd number of carbon cannot be prepared. Now I hope you understood something. Yes sir. Now we are going to do some questions. Then we will see how to produce CH4 and how to produce odd number of carbon with good yield, because these two things not coming in the Urge family. Okay sirs? Okay sirs. Now we will see some example regarding Urge family. First question. CH3 dot NaCl, it will do homolytic cleavage dot matlab heterolytic sodium matlab happens mechanism I will not dictate, one I will dictating. It will become minus, it will become plus, sodium is giving Na plus 1 electron, it will become dot. So overall we are getting CH3 dot yani 1 degree. So what we will get? CH3. Second question. Dot will come here. How? I have dictated. That much time I will not dictate to make you confused. What you will get? CH3, CH2, CH2, CH3. Third, here you will get dot. So 2 degree will do combination. Here you will get dot. 2 Cl is there. Understood? Good question. Here you will get dot. Here you will get dot. And dot combine together to form triple bond. Combination, अब don't say combination. 1 dot will come, then combination. 2 dot combine together to form 1 extra bond. Over here again. 1 dot here, 1 dot here. What I will get? Say fast. Aromatic compound here. Benzene ring. Here again. 1 dot here, 1 dot here. Single bond will become double bond. This. Acha, 1 dot here, 1 dot here. And you will form this. And it will be not the answer. Sir, just now you are doing and saying no. Why? Because when you will see it, it is anti-aromatic. Resonance. Pi sigma. And how many pi electron? 1, 2, 3, 4. And we know that 4 electron is anti-aromatic and anti-aromatic is highly unstable. Understanding? So this is not the product. What is the product coming? Combination. 1 here, 2 mole we have to take. Another mole will come, combine together. And it will form this. It will do combination. Means what is happening? 1 dot here. 1 dot here. Another compound will come. 1 dot here. And these 2 dot combine together to do combination reaction. And this is the product coming. That also you have to check. Now this is advanced question. And this one mains question also came. According to option you will take. If here 1 dot will come. Here 1 dot will come, here 1 dot will come. And these two combine together to form this. But if this is not the option, so which one is good living group? Sir, bromine is good living group. So you will make only dot in the side of bromine and another one, chlorine here, this dot combine to form this. So either this product will come for this or this product will come. So which option I will take? If this is the option, without checking you will take. If this option is not there, then go with this option. Suppose over here it will form dot. Understanding the dot. O ray, then O ray. Done. Double. Over here it will form dot, it will form dot, two dot coming, and cyclopropane dot dot combined together to form cyclopropane. Over here pH, copper, zinc, anything I will take, any urge family I will take. Suppose 12th number question, कभी कभी मेरे दिल में ख्याल. Now this, suppose over here you have taken Na dry ether. What will happen? Over here, this dot is 3 degree. What you will do? 1 as it is. Instead of that, I will write good type. This is also correct. And 1 will be like this double bond. But this structure will be not written like this. This will be written like this to look good. What will happen? Over same, both are same. Dot will come. 1 will be as it is, and 1 will be like this double bond. Either written like that, you will form this or you form this. So I hope you understand all the questions that I have dictated. So any problem in the first question, sir? No, double happened. Second question, no. Third question, no. Fourth question, 2 dot coming, that 2 dot combined to form 1 bond, not doing double. So I have given all the example. Over here, aromaticity will come after 2 chlorine. 2 chlorine, single bond will become double bond. 2 chlorine, again double bond, but problem is that here anti-aromatic coming, so we will do combination reaction. Over here, 2 dot combine, if answer is this, not, then you will remove Br, because Br is good leaving group as compared to Cl. Combination reaction. Over here 2 dot, 1 dot here, 1 dot here, combined to prepare cyclopropane. Over here pH 3 degree, 1 alkane, 1 disproportionation reaction. So I hope you understand all the bakwas what I am doing regarding urge family. So in 1 hour we have completed urge family. Now over here, what are the problem we are getting in urge family, sir? Problem in urge family, sir. First problem is CH4 cannot be prepared. First problem is CH4 cannot be prepared. What is the second problem? So second problem is odd number of carbon cannot be prepared. These two problem is coming. What I will do? So I am going to sort out the problem to produce CH4. Then I will sort out the problem to produce odd number of carbon. Understood the way of my teaching? Sir. Understood, sir. Now, next reaction we are going to see, and the name of the reaction is soda lime decarboxylation. It means first I have dictated you what is free radical. On that free radical I have dictated you about urge family. And after urge family we are getting two problems. So we are going to sort that two problems. CH4 how to prepare and odd number of alkane how to prepare. Once we will sort out these two problems, then again we will come with the topic. Understanding the logic? Sir. Good way to understand. Okay. Soda lime. What do you mean by soda? Soda means caustic soda. Caustic soda. Lime means quick lime. Lime means quick lime. Ab in caustic soda your mother is using at home for making the kachori, khasta English what I will say, easy to eat. Khasta I didn't know much. You are making that soda you are using in Italy like that. Caustic soda. And quick lime is CaO. Now soda lime. Soda means caustic soda. Lime means quick lime. And decarboxylation means removal of carbon dioxide. Removal of carbon dioxide. Removal of carbon dioxide. And this is used to prepare CH4. Not only CH4, but one of the product will come CH4 because we are facing problem in producing CH4. So we are going to sort out the problem to produce CH4. Understood? Soda means caustic soda. Lime means quick lime. Decarboxylation means removal of carbon dioxide. Now, first, some important point, then I will teach what is happening inside the reaction. First, I will teach it only. Leave. What you will do? First, you will take any acid CH3COOH. It will react with what? NaOH, it will form CH3COONA. It means in quick lime, soda lime decarboxylation, what is the reagent you are using? You are using the reagent, not reactant. What is the reactant you are using? Reactant or reactant is also called substrate. So don't get confused. Reactant is also called substrate. Substrate we are using means reagent is caustic soda and quick lime. And substrate or reactant is what? Is sodium salt of carboxylic acid. What is the substrate or reactant? Sodium salt of carboxylic acid. Now I will take sodium salt of carboxylic acid, and that sodium salt of carboxylic acid CH3COONA I will react with NaOH, soda lime, that is CaO, and after reacting what will happen? Carbon dioxide will go from here and sodium is also here. These two combined and forming Na2CO3, and this CS3 will get one hydrogen. How? I will dictate that also, don't worry. And it will form CH4. It means what is happening? CH3 minus is coming, and CH3 minus will get H plus and form CH4. Means first important point what I will write, कि sir over here intermediate is not free radical. Sir, you said I will teach all free radical together. The bachche I am teaching free radical, we are getting one problem. So we have just switched the topic. कि CH4 not prepare, first I will prepare CH4. Odd number not coming, I will prepare that, and then we will go with the again free radical. Acha sir, it means first important point you will write कि over here the intermediate is carboanion, and carboanion intermediate means their rate is directly proportional to stability of carboanion. Previously stability of free radical, rate of reaction is directly proportional to stability of carboanion. Second important point I will write, it is known as, the name of this reaction is soda lime decarboxylation. Third reaction and question also I will do on that basis, don't worry. Third name is that in this part there is a removal of carbon dioxide. Fourth important point, it is also known as awkward degradation. Means soda lime decarboxylation is also known as awkward degradation. And fifth and very very important point, directly they are asking in the JEE exam, कि over here NaOH and CaO you are using, so you have to use 3 mole of NaOH and 1 mole of CaO. Instead of dictating their mechanism, I am dictating important point from where you are able to solve the question very easily. Understood? Don't go that much moe type. Just understood what is going on. We are focusing on qualifying in JEE, not to become PhD student. Understood? It means first CH3 minus is produced. It means intermediate is carboanion and stability is directly proportional to stability of carboanion. Over here removal of CO2, and it is known as awkward degradation. And very important point, कि NaOH and CaO is 3:1 mole. Means 3 mole of NaOH, 3 mole of NaOH and 1 mole of CaO is used in soda lime decarboxylation. That's it. Understood the point? Ha sir, now understood. Okay then. Now next important point you will write, and very important, that you will say कि we are able to prepare over here methane. How? See, first reaction only I have prepared methane. Problem coming. So methane, that is CH4, can also be prepared. So by the help of Urge reaction we are able to prepare even number, and by the help of soda lime decarboxylation, methane not coming, we have prepared it. Now we are going to see line by line question over here. Understood? I am going to write some questions and we will see it very properly. Suppose first question I have written that we have CH double bond CH and here Cl in presence of Na and dry ether. Sir, this is the Urj reaction you are talking. Yes, this will go, dot will come and you are getting CH triple bond CH. But in presence of this Cl, I have taken CH double bond CH, COONA, and I have used soda lime decarboxylation NaOH plus CaO. So in this part what is happening? This will go, minus will come, this will go, minus will come, and this minus will take hydrogen, this minus will take hydrogen. So it will become CH2 double bond CH2. Understanding? It means bond will not increase, hydrogen will come. Same thing happening na. Hydrogen is coming na, 2 minus, the 2 minus, that 2 minus both will get hydrogen. Understanding everyone? Suppose C part, I have taken CH2Cl and CH2Cl and I am using over here NaZn heat. What I will do? Free radical CH2 double bond CH2. But in soda lime decarboxylation, Cl is there, but over here COONA, CH2 COONA will come. Cl will not come. So you have to see what is the reactant according to that. And arrow they will write NaOH plus CaO. What will happen? This will go, minus will come, this will go, minus will come, this minus will take hydrogen, this minus will take hydrogen, and you are getting CH3. Understanding what I am trying to say? Ha sir, understanding. Suppose D part, E part, I have taken benzene ring and over here COONA, over here COONA, over here COONA. What you will say? Ki sir, this will go, minus will come, this will go, minus will come, this will go, minus will come, and each and every place will take hydrogen, and in bond line structure no need to represent hydrogen. So this is soda lime decarboxylation. Understanding? Over here it means whenever you are seeing soda lime decarboxylation, anything you can prepare. How? If you will take CH3COONA FG, if you will take CH3CH2COONA, अच्छा GH, if you will take CH3CH2CH2COONA. What you are doing? Every time CONA removing, and in every place you are using the one reagent, that is NaOH plus CaO. First is giving us CH4, one extra hydrogen coming. Second is giving CH3, CH2 will become CH3. This is coming CH3, CH2 will become CH3. This is happening na, minus, this minus. It means CONA you are removing. So what you will say? Over here you are able to prepare, you are able to prepare odd number of carbon as well as even number of carbon as well as CH4. See, first reaction you are getting CH4, second reaction you are getting even number, third reaction you are getting odd number. It means what you will take before CONA, everything after removing CONA, you will get the final product. It means the soda lime decarboxylation has sorted out two problems. One problem CH4, another problem odd number of carbon. Both problem has been sorted out. Two problem coming, both problem has been sorted out by soda lime decarboxylation. They are important points. You will see it once again, example you will see, and everything is going to be clear. Understood the point? Now after that, once the soda lime decarboxylation completed, suppose they will give us one question. Now in this question they are asking which of the following will give more rate soda lime decarboxylation. What you will say? Sir, here it will break, became minus, here it will break, became minus, here it will break, became minus. This minus is on triple bond, this minus is on double bond, this minus is on single bond, and we know that triple bond is sp, double bond is sp2, single bond is sp3. So it has rate, negative charge is more negative charge is more stable on more electronegative atom. So C has more rate than B than A. Understood? Why? Because soda lime bicarbonate. And what is the product coming if you will use NaOH plus CaO? It will become CS3, CH3. Over here, same NaOH CaO, sir, CH2, double bond, one hydrogen will come, CH2. It will become same, sir, reagent, CH, triple bond, CH, one hydrogen coming, CO2, Na2, CO3 will go outside. Understood the point? So this is all about soda lime decarboxylation. Now, understood point, everyone? First, I have dictated hydrocarbon. After dictating hydrocarbon, I have dictated you hydrocarbon. I have dictated you free radical mechanism. After dictating free radical, I have taken those reaction that will use free radical Urge reaction. After taking Urge reaction, we got two problem. That CH4 not prepare, odd number not prepare. Then I have sorted out that two problem with soda lime decarboxylation. In soda lime decarboxylation, what is the reagent you are using? RCOONA. What you are using the reagent? RCOONA. We are gone. Here you are using what is the reagent? RCONA. Now one more reaction is there who will use RCOONA. So I am going to complete that reaction after that. Not getting confused? Understood? Sir, listen. What I am saying, first I have dictated you free radical. After dictating free radical, I have dictated you Urge family. Because Urge family will follow free radical. After Urge family, we have got two problem and we are sorting it out. After sorting out the problem, we have seen कि whatever be the substrate or reactant you are using in the case of soda lime decarboxylation, same reagent we will use in Kolbe electrolysis. So I am going to study that topic, Kolbe's electrolysis. And two Kolbe reaction is there. Electrolysis. Two Kolbe reaction. One coming Kolbe reaction that I will teach you in alcohol, phenol and ether. And one is coming Kolbe electrolysis. Both are different. If they will ask Kolbe electrolysis, that is different. Kolbe reaction, that is different. So see electrolysis written or reaction written. Why I am teaching you Kolbe electrolysis? Because first important point, it will follow free radical mechanism. First important point, because we have started this topic according to free radical only. Urge family, free radical, but suddenly problem came, then I will go with soda lime decarboxylation. But again, I told you I will return back to free radical. And second important point, over here the reactant you can say, or substrate you can say, both we are using as RCOONA. It means over here also we are using, but we are using sodium salt of carboxylic acid. It means whatever be the reagent we are using in soda lime decarboxylation, same reagent, and we are studying free radical, so we will follow both, and we are doing it so that our rhythm will not break. We will go line by line and we will understood each and everything. Understanding what I am trying to say. So don't get confused. I will make this topic very easy if you will understood and try to know what I am trying to say this. Now, in 10th class, you have studied about electrolysis. What you are doing, you have taken one water container. In that water container, you have made two hole. In that two hole, you have fixed rubber stopper. In that rubber stopper, you have put one electrode and you have put inverted tube. Connected this with one battery. Faraday electrolysis of water. That test tube, one test tube will contain this will contain water. You will put few drop of H2SO4. Then both test tube will get bubbles. And if you will put burning candle, if burning candle will comes as a pop-up sound, hydrogen gas. If burning candle will not coming as a pop-up sound, oxygen gas. That you have studied, na? Ha, sir, we have studied that. It means over there in electrolysis, what you are using? Electricity you are using. After using electricity, second thing, what you are getting? You are getting one anion and one cation. Hydrogen plus, it will go on anion, cation, and oxygen minus, it will go on anion. Means electrolysis means electricity. It means, understood, don't get confused. Why I have teaching you Kolbe electrolysis? Because first we have started free radical mechanism, and we are studying free radical, so I am continuing this free radical after soda lime decarboxylation. Soda lime decarboxylation, why you have taught? Because in free radical of Urge family we are not able to prepare CH4 and odd, so soda lime has sorted out that. After that, why you are teaching Kolbe? Because I want to return back to free radical mechanism, as well as same reactant we are using in the case of soda lime and same reactant we are using in the case of Kolbe electrolysis. Now, whenever I am writing electrolysis, means electricity will use. If electricity will use, when someone is anode, someone will cathode, anion will go to anode, cation will go to cathode, means you know that whenever any place I am writing anode, it means it is positive. If I am writing cathode, it means it is negative. If I am writing cation, it means it is positive. Whenever I am writing anion, it means it is negative. Cation, anode positive, anion negative. Cathode negative, cation positive. So if I will do electrolysis, so some cation will form, some anion will form, and cation will go to which part? Positive will go to negative. It means cation will go to cathode and anion will go to anode. Why I am studying this? Because we know that electrolysis, and in electrolysis some cation, cathode, anion, anode will be there. So cation C will go to C, and cation will go to cathode and anion will go to anode, because cation is positive and cathode is negative. The positive will go to negative, anion is negative, anode is positive, the negative will go to positive. Understood this part? In this part, what is the reactant you are using? CH3CO and मतलब RCO and sodium salt of carboxylic acid. Achha. What happens? Understood now. First of all, we will come at anode. Electrolysis is there, means anode cathode must be there. Now, first I am taking the topic anode. In anode, what happens? First I have taken RCOONA, so O minus. What we have? RCOONA, so we know that RC double bond O, Na minus plus, so I have taken RCOONA. Now, what will happen here? Understood the point very properly. This part they will do free radical. This part they will do free radical. Now after doing free radical, it will get one electron, and after getting it, R will become dot. Understood the point very properly. And carbon dioxide is going outside. What is like that? How it is happening, sir? Just wait. I will dictate you. Don't worry about it. What happens? This will come here. It is forming this, and it will take one electron. How? Not like this. Understood what I am saying? This is total carbon dioxide. It will go outside. More electronegative. This will do resonance. What happens from here? Carbon dioxide will go outside, and it will become plus. Someone will give him one electron over here, and it will become R dot. Main important point ki what is forming? R dot. First important point over here ki reactant is sodium salt of carboxylic acid. Second important point is that anion will go to anode, cation will go to cathode. What happens at anode? Anode needs negative charge, and carbon dioxide has negative charge. Carbon dioxide has negative charge, so this reaction happens at anode. Now carbon dioxide will go, R dot is coming. R dot, if it is 1 degree and 2 degree, it will do combination, because dot. Same thing not happens in the case of soda lime, because over there no dot. Over there minus sign is there. It is possible only for dot. And if it is 3 degree, it will do disproportion. I will do some questions also, don't worry. Disproportion. Now at cathode what happens? Anode to done. Acha sir. At cathode, what is the reaction happening, sir? So at cathode what happens? Ki water is there. You are doing this reaction in presence of water. So what will happen? Because electrolysis, name is only electrolysis. Electrolysis you are doing electricity they giving, but water also there. Electrolysis means addition of water also. What happens over here? OH minus will go, H plus will come, and it will form half H2. Why? Only one hydrogen is there, that will form half mole of H2, and Na plus coming from here, that will react with OH minus, means what you will say. First important point, understood what is happening over here. At anode, carbon dioxide and free radical is forming. Carbon dioxide will be as it is, free radical will be converting 1 degree, 2 degree combination and 3 degree disproportion. And at cathode, which gas is coming? Hydrogen gas is coming. It means I am going to write each and everything very properly as an important point. See it once, fast. Seen this? Sir, seen. Little bit. Understood, sir. It means at anode, carbon dioxide and free radical, and at cathode, half H2O coming, hydrogen gas is coming. Now I am going to write slowly the important point. Just understood. Some important points of Kolbe electrolysis. Then I will do questions and I will make you confident on that also. Don't worry. Some important points. What are the important points, sir? See, everyone. First, which mechanism we will follow? Sir, we are following over here. First point, we are following free radical mechanism. First important point is free radical mechanism. Second important point, which gas is released as carbon dioxide? Which gas is released as anode? Sir, this point I never forgot. Carbon dioxide gas evolve at anode. How you will check this gas is carbon dioxide? They will passes through lime water. What is the formula for lime water? Lime water is also called, class 10th we have studied this, everyone, slacked lime. Slacked lime formula is CaOH whole twice. When you will pass carbon dioxide with this, it will form CaCO3. And if you will pass more excess carbon dioxide and water, it will form CaHCO3 whole twice, and that is insoluble in water. Means what I am dictating, I will go back. Carbon dioxide gas evolve at anode, passes through lime water, turns lime water into milky white. And you have studied in class 10th. Lime water convert to milky white in the presence of carbon dioxide. So at second point, carbon dioxide gas is evolved at anode. And one more point you will understood कि whenever you have carbon number 1 to carbon number 4 like CH4, C2H6, C3H8, C4H10, these four there, these are gases. These are gaseous in nature. But if you will have 5 carbon to 17 carbon alkane, then this is liquid in nature. And whenever you have 17 to so on, all the carbon are solid in nature. So you can write the carbon dioxide gases evolve at anode, as well as if this carbon is one carbon CH3 dot or C2H6 dot, we will do combination. Suppose over here CH3 dot, it will form CH3. After doing combination, it will form 2 carbon, and this is also gas. So there is a chance that another gas will also produced over here. Carbon dioxide to coming, if the carbon is 1 to 4, it means third important point, the alkane formed may be gas at anode. If it is C3H8 or C4H10 or C2H6, anything is there. What are the things formed? Sir, over here again combined free radical, so CH4 to not coming as a gas. Sir, it may be that double carbon will come, CH3 come. Acha sir, CH3, CH2, CH3, that will also not come. But there is a chance कि CH3, CH2, CH3, because free radical is always giving even number of carbon. So there is a chance that C2H6 as a gas will come at anode, or C4H10 will come as a gas as anode. But carbon dioxide to always releasing. So the alkane may be gas at anode, not gas, no problem. But up to 4 carbon, there is a chance of gas. Fourth important point, which gas is released at cathode? So you will say, sir, H2 gas evolve at cathode. They are asking the question like this, which gas is released at anode, which gas is released as cathode. Acha. Fifth important point, whenever you are doing the reaction, what you are getting over here, see, at last you are getting NaOH. And if you will see the solution is basic or acidic? Sir, basic. Yani overall solution is basic in nature because NaOH is coming in the last. If overall solution is basic, then pH is increasing or decreasing? Sir, increasing because pH 1, 2, 3, 4, 5, 6 is acidic, 7 is neutral, 8, 9, 10 to basic, to 8, 9, 10, 11, 12, 13, 14 coming and pH increasing. Seventh important point, कि sir, soda lime decarboxylation has helped us to prepare odd number as well as CH4, but over here again we are not able to prepare. CH4 cannot be prepared. Same problem as we have got in Urge family, and also odd number of carbon cannot be prepared. Odd number of carbon cannot be prepared. But why you have taught this, sir? Because just now we have completed the soda lime same reactant. So I have taken second important point, कि sir, same reactant as well as free radical, and we are continuing free radical mechanism. So I hope slowly you are understanding hydrocarbon and not feeling bored. Now we are going to see some questions on this basis. If we will see some questions over here, what we will get? Sir, over here Kolbe electrolysis means free radical. Free radical means 1 degree combination. Acha, soda lime decarboxylation, no, carbo anion minus. It means what it will form? It will form CH4 methane. Over here Kolbe electrolysis, free radical, CH3 double bond. I have written over here more CH, H is 2 only. H is 2 only. Don't get confused if I am writing my mistake, but I will try not to write. So what it will get? CH2 double bond CH2. But if it is soda lime decarboxylation, CH3 single bond CH3, because minus is coming and minus will take hydrogen. Kolbe electrolysis dot CH triple bond CH. But soda lime CH2 double bond CH2. Over here we can't use soda lime because soda lime at least one to needed na hydrogen carbo anion to form na. So over here NaOH plus CaO you can't use, but Kolbe you will use. What you will get? You will get hydrogen gas at cathode and carbon dioxide gas at anode. No alkane is formed. Only carbon dioxide and hydrogen gas. Acha, in Kolbe electrolysis, instead of CONa, sometime if SO3Na given, also don't get confused. Over here again you will get the same thing. Free radical will do CH3 single bond CH3 combination reaction. Over here it will break free radical. Kolbe electrolysis CH3 soda lime CH4. Understanding na? Not getting confused na? Acha sir, the question is done. Understood now? So see, first we have seen free radical. After seeing free radical, we have seen some questions on this basis. Then we have seen the free radical reaction, and that is Urge family. After seeing the Urge family, we are getting two problem, and to sort out that two problem, we have seen soda lime decarboxylation. After that, same type of reactant coming in soda lime decarboxylation as Kolbe electrolysis. So we have seen Kolbe electrolysis. Now, one problem we have solved already. One problem is odd number of carbon cannot be prepared in Urge family. Odd number of carbon is not prepared in Urge family and Kolbe electrolysis. But this problem has been sort out by first soda lime decarboxylation. Soda lime decarboxylation. But there is one more reaction that will sort out this problem. So we have to study that reaction also, and that is called Core-House reaction. So we are going to, this problem has been sorted out by the another reagent, another reaction that is known as Core-House reaction. So we will study that. Means problem of getting odd number of carbon has been sorted out by soda lime decarboxylation. But one more reaction is there, they will sort out this problem also. So we will study that problem also. Understood? How correlating, see, learning to there. But if you will correlate the topic slowly, you will understood each and everything regarding hydrocarbon, and it will become very easy. Once you will understood hydrocarbon, one shot 4 to 5 hour, how many hour I didn't know. After that I will give lots of JEE mains advanced question one topic, and I will dictate that. Don't worry about anything. Understood? Now we will have Core-House reaction. What we will have? Core-House reaction. Why? Logic understood, reason understood? Sir, because odd number of carbon you have sorted out the problem with soda lime dicarboxylation. But you know that in this world lots of people is there to sort out the problem. Like that, I am here for you to sort out your problem. How much I am sorting out your problem, that I didn't know, but I am trying from my side. Some other is also trying. Lots of videos are there, you can watch. It may be that video looking much better than me, but trust me, on content purpose I can't give guarantee, because more talented teacher are there rather than me. But I am trying to make the topic funny and easy. Funny not in the sense of became joker in the class. Funny in the sense I will try to dictate you. Understood? First important point, see. First I will teach you Urge family. In that, free radical. Then Kolbe electrolysis, free radical. Soda lime, NaOH plus CaO, carboanion. And Core-House, also carboanion. It means two free radical reaction you have studied, Urge family and Kolbe electrolysis, and two carboanion reaction, that is Core-House and soda lime decarboxylation. And both reaction is used to sort out the problem of odd number of alkane. But soda lime is also used to sort out the problem of preparation of methane also. So over here what you will say, in this reaction the intermediate is also carboanion. If intermediate is carboanion, I will write the story after that. First see what is the reaction over here. First you have to take alkyl halide, and that alkyl halide, first reagent you have to react with lithium. Second reactant you have to react with copper halide. Copper halide. And third reagent you have to take as R-X, some other R-X. What will happen? It will give R. How? I will dictate you. It means what is happening over here, this R and this R combining together and form one product. Now I will see what is happening in this reaction. But important point, R and R dash will not be aryl compound. Any benzene compound is not there. That you have to learn definitely. R and R dash will always be alkyl only. Don't use any benzene ring over here. Not alkyl only we will use. Now see. What you have written the reaction we have to learn as it is. Yes. Now see the mechanism. What is mechanism means? Suppose you are eating the food, and now some food will give you vitamin, protein, carbohydrate. But I will tell you what is how your digestive system will work and how it is doing to be happen inside the body. So that mechanism. First mechanism, what happens? You will take 2 mole of alkyl halide and you are reacting this with lithium. 2 mole of alkyl halide reacting with lithium. What happens? 1 mole of alkyl will form lithium alkyl and 1 mole of lithium will form LiX. After that, again you have to take 2 mole of RLi and you have to react that with Cu copper halide, CuX. What happens? It is forming a compound like this, R, Cu minus and R. If you will write this compound very properly, what you will get? R2CuLi, R2CuLi, and this reagent is known as Gilman's reagent. It means while doing the Core-House reaction, in the intermediate we are getting one another scientist reagent that is known as Gilman's reagent. Then you will take this R2CuLi and react with R dash X, and from this R and R dash will come. This is the mechanism happening inside it. First important point, carbanion, and whatever be the R and R dash, that will form. Understood? No problem in that. Now, a problem is there, see once again. Something is very fixed that you have to know. Now over here we will going to write stereochemistry. If I will write important point someplace stereochemistry, both have the same meaning. Don't get confused ki sir you are not written stereochemistry there. If I will remind, I will write stereochemistry or important point. Both have the same meaning in the chemistry part of organic chemistry. First important point, what is the intermediate? Sir, intermediate is carbanion. I have written in the first part. It means second important point, rate is directly proportional to stability of carbanion. Acha sir. Third important point, in this reaction Core house, we are getting one more important reagent, that is Gilsman reagent, R2CuLi. So in this reaction of Core house, we are getting one important reagent. And what is that important reagent? Gilman's reagent in the between. And what is their formula? Sir, their formula is R2CuLi. We are getting one important reagent, and that reagent is Gilsman's reagent. Again, over here you are not able to prepare CH4. CH4 cannot be prepared. Again, I will write some example. Don't worry about that. Now, fifth number, in this part you are able to form even, that is symmetrical, or odd, that is unsymmetrical. Both product can be obtained. In this part, both product can be obtained. Now we are going to see some questions. Then Core house also moe. Now we will see the question, not that much to worry. See, over here what is R? Over there what is R? Combine that. CS3, CS3. Leave other things. Over here what is R? Over here what is R? Combine that. CS3, CH2, CH3. Over here what is R? What is over here R? Combine that. CS3, CH2, CH2. After that CH2, CH3. Over here you are able to produce even number of carbon, odd number of carbon, 1 2 3 4 5, odd number of carbon, yani even and odd both will form. Over here you can't take HX, because in the reaction only I have written what? RX you have to take, and here also you have to take RX. So H not coming. Suppose someone will say, sir, RX over here, CH3H over here, it will combine and forming CH4, but the problem is that we are not able to take this. Understanding the point? So this is not a valid point. So again we are not able to produce CH4. What we are not able to produce? CH4. Same thing I have written. And CH4 how we will produce? By using bolo bhai, say soda lime decarboxylation. Yes, it means up to now whatever the reaction we have studied, in that odd number of carbon can be prepared by soda lime as well as Core house reaction. Even number of carbon can be prepared by Urge family and Kolbe electrolysis. Urge family and Kolbe electrolysis follow free radical mechanism. And soda lime decarboxylation and Core house reaction follow carbanion stability. Carbanion intermediate is carbanion. Soda lime decarboxylation will give CH4 as well as only one reaction over here we have studied, that will give CH4 as well as odd number of carbon and even number of carbon. But Core house will give odd even, but CH4 it will not give. Understanding what is happening now. After this we have to study Grignard reagent. What we have to study? Grignard's reagent. And Grignard reagents in this chapter I have dictated you each and everything very detailing in one video. If you will need, you will go to the channel and you will see Grignard reagent thumbnail. If you will say, sir, not getting, just now I have made only 10 videos, 11 videos, 12 videos. So it is not possible to not get in the playlist or in the video section. You will get Grignard reagent and that you will see. But right now I am going to write some questions on Grignard reagent. What is Grignard reagent? What is the reaction? I will not dictate because that individual video I have already made. So I will waste the time. Understood the point? So I will write some questions over there. Now we will see the Grignard reagent reaction. Over here I have already dictated you कि RMgX is the Grignard reagent. Active hydrogen needed. So hydrogen will come, you know that it will break from here, it will become minus, it will become plus, it will give H plus, it will also give H plus. How? You will see in Grignard reagent and you will be able to understood. Over here you will get RH, over here also 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 you will get RH, but over here R and CS3. Over here H not coming, this will come CS3 plus. All the time, if CS3 alkane is not there, SH, COH, Nakuns, QHX I have dictated in the case of Grignard reagent. Please see. Everyone will see the Grignard reagent video because every chapter has Grignard reagent and I don't want to dictate every time Grignard reagent. And over here, this will become plus and it will become R, CS2, CH3. So this is all about Grignard reagent. A question I have written how you are judging which one is give H or no. For that I have given the trick Nakuns QHX. Now, I personally believe I have already made the video of 1 hour 41 minutes and I am making this video on iPad. Problem is that if I will not upload this video to already 1 hour 41 minutes, it may be that video will getting disrupted or something bad, so I will have to cry. So I will stop over here. Tomorrow I will dictate you the remaining part of the hydrocarbon, means max to max 3 video I will complete all the things, but I hope up to now what I have dictated is very interesting and very good for you all. Please see it once again. If any confusion you can ask. Bye. Have a nice evening. Enjoy. Take care. Stay home. Stay safe.